Let's have a look at this one first. Now, is this a quadratic?
Yeah, maybe.
What do we reckon? Well, what's the condition for it to be a quadratic?
It must be three A, B, C.
Not always, because I could write something like this down. That would still be a quadratic, right, even though there's not an x term. So what's the condition for something to be a quadratic, to be classed as a quadratic? What does it have to have in it?
X squared.
Okay, so it has to have an x squared, but I'm like, hang on a minute, there's an x squared there, but it's not a quadratic. Why? It has to be the highest power of x, which is 2. Okay, so even though there is an x squared in there, there's a higher power still. There's a power of 4, right? So this in its raw form is not a quadratic. Does anybody know what the name of this polynomial is? It's a quartic. Okay, so quadratic is for 2, quartic is 4, right, to the power of 4. Okay, fine. So it's not quadratic, and we definitely don't look at how to solve quartics in this course because they're a beast. But how could we go about solving this? Anybody got any suggestions? Yeah, Riley.
Can I write it?
Yes, of course you can. What Riley's done. So basically she has said, well, hang on a minute, I'm noticing that there is a pattern going on there. I'm noticing that I've got an x squared term and the other term, the power is twice as big. Now we've seen that before, right? We've seen that with quadratics. Because if I write something like this down, something like that down, for example, okay, you notice the power of that is 1, power of that is 2. So in order for it to be a quadratic, another way which we can look at this is that that power is always double that power there. Okay, so notice this, that power is double that power there. So it is a kind of quadratic, like it follows the same form. In fact, we can extract a quadratic out of this. So we call this a hidden quadratic. Okay, so there's a quadratic kind of hiding in this equation. It's a quadratic hiding in this equation. Okay, so let's talk through what Riley's done here. So Riley, you've said t equals x squared. I definitely agree with that. What have you written here? You're right. Yeah, so that's the condition. So you're basically saying this can only work as long as t is greater than or equal to 0. Can anybody think, why can't it be negative? Why can't it be less than 0?
Because if it's squared, then it's got to be...
Absolutely. So you're basically saying t is equal to some number squared. Well, if you square any number, what's that always going to be?
Positive.
Positive or 0. It can never be negative. Okay. Now that's not strictly true. It can be negative, but we don't know how to deal with it in this course. Okay. So for the sake of this course, we need to make sure that t is always non-negative, so positive or 0. Is that okay? Okay, fine. So if you let t equal x squared, clearly that just becomes a t. So you get 3t there. And are you happy that x to the power 4 becomes t squared? Because you can write x to the power 4 as x squared squared. Happy with that? We've done the laws of indices. Is that okay? Yeah? So what we've got here then is definitely a quadratic. The highest power is definitely 2. So t squared minus 3t minus 4 equals 0. Fantastic, thank you. Okay, and I think we know how to solve this. So how could we solve this now? How would we factorize it?
X negative 4 plus times x plus 1.
Okay, so t here, t here. So you're looking for two numbers that multiply together to make negative 4 and which add together to make negative 3. What do we get?
Negative 4 and 1.
Negative 4 and positive 1. You happy with that? Okay, and then when you're at this stage, could you finish it off for me? I know Malcolm, you said it.
T is equal to 4.
Yep.
Or t is equal to negative 1.
Good. Well done. Make sure you put the or there, right? Because it can't be equal to both. Now we're here. What are we going to do?
Square.
Right. So you remember we're not quite finished here because t is equal to 4, t is equal to negative 1. Fine. But remember we had a quadratic in x, so we need to go back. But are you happy that we can rule a solution out at this stage? Which one?
Which solution we can what?
So we've got two values for t. Are you happy that we can rule one of those values out? Which one?
Why would we?
You happy that we rule this one?
Yeah.
Because look at the condition up here. Look at the condition up here. T has got to be greater than 0 or 0. Yeah, it can't be negative. So in fact, we have to rule this one out. Okay. And just for clarity, I am going to stick with it, even though we can rule it out at this stage, just to make sure that everybody's on the same page. Okay. So would you be happy then, because t equals x squared, that means either x squared equals 4 or x squared equals negative 1. Okay. Hopefully you can start to see here why this doesn't make sense. So if x squared equals 4, what must x be equal to?
2.
It could also be negative 2 as well. You remember where it came from? Okay. So positive or negative 2. Okay. But then you're here. You're like, some number squared, and it comes out as negative 1. If you think about it, any number squared, whether it's positive or negative to start off with, has to be positive or 0. Yeah? So this doesn't have any solutions either. So it doesn't matter where you rule it out. You can rule it out here. You can rule it out here. You could even write down this next line and go x equals the square root of plus or minus 1. Any stage you can rule it out, but as long as you rule it out. Okay? Now I need to see, in an exam question for example, I need to see that you have definitely made a clear attempt to exclude that solution. Okay? So don't just leave it in there, sort of put something down to the fact that t has to be greater than or equal to 0. I like that. Okay? Or t cannot be negative. Yeah? Something like that, just to say, this is why I exclude it. I understand what's going on here. Okay? So the two solutions to my equation are x equals positive 2 or x equals negative 2. Is that okay with everyone? Good, fantastic.